isn't there, but you can still see the top of the pylons.
Ah. What pictures from space, man?
What
Pictures
space
of the
first?
Earth space.
Yeah, what space first? Let's just like let's all get together and define what space is.
Read off of Google.
No, not Google. What do you think space is?
Area of extremely low pressure
in between celestial bodies.
Sorry, what?
The vast
Someone asked for
in between celestial bodies.
the vast expanse between celestial bodies. Yeah, that's pretty good. Yep. And how does that differentiate between where we are?
Yeah. How do you
living right now?
Because we're on a celestial body.
Okay. Are you breathing on this celestial body?
Yes, I'm breathing on the celestial body because it has an atmosphere tied down by gravity.
Okay. Atmosphere by gravity. What gravity are you talking about?
Gravity from the Earth. The Earth's core has gravity.
So you mean the Earth's core is pulling things down towards it?
The entire Earth is pulling the gases in the atmosphere towards the Earth, yes.
And where are most of the gases created?
At the bottom, closest to the Earth.
So around about sea level?
Gases are densest at the very, like the surface of the Earth.
So gases are created at around about sea level, correct?
No, not sea level. At the surface of the Earth.
At or around about sea level is what I said.
Sure.
Is that correct or not?
I don't know if this is correct. If it's at sea level, I can Google this. I can Google where is the atmosphere the densest.
How about I save you a Google search and I'll say that we can agree that most gases and cycles are produced at or around about sea level.
At or around about the Earth's surface in the troposphere.
That's where all the organic material is, at or around about sea level, correct?
No.
So not all the organic material is at or around about sea level?
No, that is incorrect.
Where is all the organic material then?
The organic material? All of it? All of it is on the Earth or in its atmosphere.
So we're talking about the gas cycles, yeah?
The who?
So we are talking about gas cycles and where they are produced.
I was asking you how you explain pictures of Earth from space. What the fuck are we talking about?
No, so you implied an atmosphere?
You asked me how we breathe, and I told you that the atmosphere is chained to the Earth by gravity. You never answered my initial question. How do you explain?
He's trying to, but you keep talking.
Well, no, I want you to explain in simple terms why we have pictures of the Earth being a globe from space.
They're all bullshit because of entropy.
Let's go back to us. Let's go back to us breathing first.
Oh, you have evidence that they're fake?
Let's go back to us breathing here on Earth first, yeah?
No. You have evidence that they're faked? Do you have evidence that they're faked?
No, that's where we're getting to. Right?
No. I'm asking if you have evidence if they're fake. This is a yes or no question.
What, if the pictures from space are faked?
Yes.
We've got 6 hours of ISS fakery. Would that be enough for you?
I'm sorry, could you repeat that?
Okay. We have 6 hours of ISS fakery. Would that suffice?
No.
Really? So NASA's own video footage is not good enough to combat your so-called...
at the very edge of our atmosphere. It's not in space.
So 6 hours of NASA fakery would not suffice?
No.
And you're talking about 1 or 2 photographs to compete with that.
It would bring into question NASA's credibility. Sure, but there's other agencies
Excellent.
who have sent probes into space that have taken pictures of the Earth.
Like? You don't get it,
Other
do you?
space programs?
Space is fake.
Other countries' space programs, SpaceX.
Yeah, so that's a great story, bro. How are you going to validate this?
What is space? Tell us what space is.
They've been correct about just about everything else.
What is space?
Space is the vast expanse between celestial bodies.
Okay, and that would be represented in a pressure of what particular torr?
Space is a vacuum. There is no pressure in space.
No, there's a particular torr value that they give to space. Do you know what that is?
I don't know the exact value, no. Could you enlighten me?
Okay, 10 to the negative 17 would be outer space.
That is torr. A ridiculously small number.
But an amazingly small number. And then we are standing on Earth here at 14.7 psi, which is 770 torr.
Yeah.
Do you see a problem? Yeah. Do you see a problem with?
No, because we have an atmosphere.
So we have gas pressure of 770 torr where we breathe. Yes. And then there's a place out there with 10 to the negative 17 torr, and you don't see any issue with that.
No, I don't. Why would there be an issue with that?
Okay. So let's say, for example, I'm sitting in my classroom, which I do regularly with my kids, and I have a a vacuum chamber, which I can evacuate to 10 to the negative 3 torr. Let's say I evacuate that chamber to 10 to the negative 3 torr, but I have inside it a box which I had already pre-prepared atmospheric pressure of 14.7 psi, which is a standard pressure of our atmosphere. I evacuated that chamber as much as I could. Then I took the lid off the other box, which is inside, which has got normal gas pressure. What would happen to that gas that was in that box that I took the lid off?
Well, the gas has normal pressure while it's under a vacuum, right?
The gas in the box is normal.
The gas inside the box is under STP, while
the gas in the box has got normal 14.7 psi sea level pressure. Mm-hmm. I've evacuated the chamber, but I've taken the lid off.
So the chamber's a vacuum, but the box inside, after you turned on the vacuum, it doesn't expand; it stays the same.
You need to listen. So the box that I have normal atmospheric pressure in, I've just taken the lid off it inside an evacuated chamber. What would happen to the pressure inside that box that's inside the chamber?
It would all be released and dispersed into the chamber.
And did gravity hold it down?
Gravity did not hold it down, no.
Okay, so how does gravity hold our gas pressure that we breathe from not evacuating into the expanses?
Is
not letting me.
The mass of the gas that is holding in.
All you need to do is let me finish my sentence, then I'll let you go for it. How does the pressure that we breathe, which is 14.7 psi, graduated over distance and height, how does that not evacuate into the expanses of 10 to the negative 17 torr of space?
Because of the Earth's gravity.
We just defeated that with our little test of our vacuum unit.
No, the little test was on the Earth's surface in a closed system. The gravity of the Earth was acting downwards on both of those gases. The box itself that was inside of the vacuum chamber did not have sufficient gravity to contain the gas particles within it. But the Earth's gravity
level where it's strongest.
The gas particles.
Where is gravity the strongest? Where is gravity the strongest?
At the center.
Center of what?
The mass.
So if we were talking about where we live, i.e.
we live on the surface of the Earth.
Surface of the Earth, where would gravity be strongest for us?
Directly on our feet, under our feet. Yeah.
Okay. So we've just defeated that whole bullshit premise that you just presented by opening a box
How have you
inside
defeated the premise?
evacuated. You're not going to let me finish. We've just opened a box, 14.7 psi, inside an evacuated chamber, and we've agreed that that pressure would expand into all the areas of that evacuated space, and gravity did not hold it down at the area where gravity would be the greatest in which we stand, yet
These
it
are not analogous
is
systems.
held. It is held at a particular line in your heliocentric model, which stipulates that the Kármán line, there is some magical force that just has the graduated levels of density of air modulate out until it just has no activity.
Completely non-analogous systems. The box and the vacuum chamber is not the same as the Earth in space.
Where is gravity the strongest?
The center of the mass.
So for us as humans, the gravity would be strongest at or around about the place that we stood on or worked on or lived on.
Well, yeah, because we cannot travel to the Earth's core. If we were in the Earth's core, gravity would be significantly stronger. In fact, we would be crushed.
Cool story,
no
bro.
drama. I'm only talking about where we're standing on. So I have my
Where we're standing, yeah, gravity would be strongest at our feet.
Okay, I have my the vacuum chamber, which I use daily for my students, on sea level. So at or around about sea level, where for us, the gravity is the strongest. And I can put inside that gravity chamber a box of air pressure, which I've already presented, from the pressure that we are living and breathing in, by putting a shoebox inside my vacuum chamber, evacuating the pressure from my vacuum chamber. If I take the lid off the shoebox and I let that 14.7 psi into that vacuum chamber, we've already agreed that it will expand into all areas of that vacuum chamber.
Yes.
And at that point in time, gravity has nothing to do with the ability for that gas to move in all directions, because that's what gas does.
There is not a sufficient gravity to hold that gas and create an atmosphere inside of that vacuum chamber or that box.
So there is not a sufficient amount
together.
of
It pulls a smaller mass to a larger one.
So does gas get pulled down to the mass of Earth or not? What does this have to do
with the pictures of Earth from space?
Now, what this has to do with is the topic that was brought up, and that was that gravity, which you used, was an explanation of why gas pressure is not contained on this Earth. And we just defeated that, literally, by a simple experiment that we could do, anyone could do.
Your experiment is not analogous to the example that I was given. So your experiment is not the same and is not reflective of atmosphere.
Why not? Gas laws apply on all scales.
Because the scale is completely different.
Okay, did you not hear? Gas laws apply on all scales. That's why they are laws.
Gas particles are held by larger gravities. Right? So if I have, let's say...
Okay, obviously you're fucking stupid, not just deaf. Gas laws apply at all scales.
Yeah, gas laws do, as in things like pressure and temperature, things like Bohr's law, or... I don't fucking know. Like, yeah, the different gas laws, like thermodynamics, yes, those apply at different scales. When you're moving, when you decrease something's pressure, its volume will increase. It's things like that. Yes. However,
so if you've got a high pressure container next to a low pressure system, if you pull the lid off it, what happens?
If I pull the lid off of it,
Yep. You've got a high pressure container. On the outside of it is a low pressure system. What happens when the container gets removed?
The high pressure moves to the lower pressure.
Excellent. Please
Yes.
continue, Jardo.
All right. Now that we've worked out the second law of thermodynamics, so we can literally defeat the Newtonian or mechanical version of gravity, correct?
I'm sorry, how?
Because we just defeated the fact that gas is held down by a particular mass, which we call the Earth, because gas moves in all directions.
I think you're having a misconception here.
Move.
The word
Gas
down is doing a lot of
moves.
heavy lifting there. Gas is being held towards a mass because the mass is so super massive, it creates an atmosphere. There is a reason why something like a marble doesn't have an atmosphere around it the same way that the Earth does, because the difference in size, the difference in mass between these gas particles and something like the Earth is so great that the gas cannot escape the Earth's gravity, thus it creates an atmosphere.
So if the gas can't escape the Earth's gravity, how come with our little experiment and you agreeing when we say open up a can of Pepsi, the high pressure is released into the area that has less pressure? But we're not talking about gravity here. We're talking about just a law of thermodynamics.
Why is the atmosphere contained onto the Earth, or why does the pressure inside the vacuum chamber
No.
move from high to low?
You have this preconception that the atmosphere is contained on the Earth because of the Earth's pull of mass.
Yes, this is something you can Google.
Not Googling anything. What we're talking about is, for me, 15 years
Why are you not Googling things? Do you not believe science as we know it to be reliable?
Science has got nothing to do with gravity. Can you give me a scientific
Gravity
proof of gravity?
is a scientific theory.
Can you give me, okay, so what's the hypothesis of that theory?
The hypothesis of there is. Let me Google really quick. Gravity
Okay. Go Google away, and then what you need to do is you need to give me the observed phenomena, and then you need to give me the hypothesis.
The phenomena is that things of lower mass are pulled towards things of higher mass. We observe this consistently. Something like an apple is pulled towards the Earth when you throw it upwards.
When you so what you need to do is you need to give me the observed phenomena first that happens in nature. Then you need to give me
the observed phenomenon. The observed phenomena, right, is when you throw something like an apple upwards, it is pulled back down towards the Earth.
So observed phenomena in science is something that happens in nature.
When something is released out of a tree, for instance, a fruit becomes too heavy for the tree to hold, instead of being suspended in space and being able to sit on the tree as long as it would like, it snaps part of the tree and it falls to the ground.
Great. So how did it get to the place that it was in the first place before it fell?
The tree grew upwards and then grew the plant, the fruit out of the branch.
Okay, so we had a defiance of your so-called dependent variable before we had the dependent variable of the something falling.
Gravity when the tree grew upwards.
The tree grew upwards, defying your gravity.
Things growing upwards does not defy gravity. It has a structure that is resistant to gravity. If it was something that had no mass, or not even no mass, if it's something that had like a really weak structure, right, and it grew directly up, it would begin to sag because of gravity. But because it is a tree and it has a ton of cellulose and things like that, when it grows upwards, it has a sturdy structure that can resist the Earth's gravitational pull. But if you were to put that same structure on something like Jupiter, it would become crushed immediately.
Cool story.
Okay, so let's say, for example, we had an apple tree that grew and some apples grew on it, and an apple fell off it, that would be conclusive evidence of gravity.
Yes,
Correct?
because the force of gravity pulling down on the apple is stronger than the force of the stem holding it to the tree.
Right. Okay, I got it. What happens if the apple fell into a pond of water?
A bunch of water?
A pond of water. What happened to the apple then?
The apple would it would splash into the water, be pulled under its surface for a little bit, and then bounce onto the and then float on the surface because of buoyant force. Because the buoyant force acting upon the apple is greater than the gravity pulling it down.
Right. So we
Well,
have
they're about
another. So we have another force which we could classify as density relative
density is
to
not a
the
force;
apple
it is a property.
pushing. Sorry.
Density is not a force; it's a property.
So if density is not a force, then what happened to the apple when it hit the
That
water?
it was pulled down because of gravity, and then pulled back up because of the buoyant force.
It was
Buoyancy
pulled
is
down.
the buoyant
It was
force. That is
pulled
a force.
down.
Buoyancy is a property. Density is a
It was
property. Color is a property.
listen. It was pulled down because of its acceleration force. What if I was to just place the apple on top of the water? Would it sink under the water or would it float?
If you simply placed the apple onto the water perfectly, it would be floating.
Okay. So how does that happen then in your gravity?
In my gravity, because the gravity and the buoyant force are about equal.
So what if the apple was made of helium? What would happen then?
The apple would float out of the water and into the atmosphere.
Okay. Is the gravity pushing the apple down because it's made of helium, even though helium has mass?
Helium's mass is much smaller than that of an apple. Therefore, the helium has even lower mass than the normal gases in our atmosphere. So it would begin to shift up the atmospheric column, maybe into the
So
troposphere, above the troposphere, into the stratosphere. The
does
same
helium
way a
have mass
helium-filled
or
balloon would.
not?
In fact, you can observe this by filling a balloon with helium and watching it go up.
Yeah, I know that. Does helium have mass or not?
It has a very low mass.
But it has mass.
It has mass, yes, it's just very low.
Okay, so that mass should be pulled to the center of the Earth just like all the other mass?
No, it doesn't get pulled to the center of the Earth because the mass is at around the same level as a lot of atmospheric gases, right? Because that's where helium is. So it would actually float in the atmosphere the same way that the apple would float in the water. It wouldn't go off into space, it would be in the atmosphere.
Nice. Very good. We're getting there. So, does helium have mass or
Yeah,
not?
yes, it does.
Right. And does your particular version of gravity, that is the center of a larger mass, pull all mass towards it?
Yes.
Okay, except for the apple that's made of helium.
The apple that's made of helium? Yeah, no, it would not be pulled towards the center of the earth because the buoyant force of acting upon the apple would instead be through the fluid of the atmosphere. Atmosphere is a fluid, so there is buoyancy there too.
So, what you're saying now is that gas is a fluid.
Gases are fluid, yes.
Uh, you know that gases are not fluid, they're gas, yeah?
Did you know that fluid and liquid are not the same word?
Gases show signs of fluidity depending on temperature
Gases are
and
fluids.
thermodynamics, but gases are not fluid.
Google this, please, for me right now. Gases are fluids.
Mate, I've been through this for the last 15 years with you
I'm
guys. I
Googling it
don't need to
right now
Google
for
anything.
you. Gases are called fluids. Literally
Okay.
anybody can Google this for you.
The gases have elastic collisions and isotropic. homogeneous, they move and accelerate from which the direction that they were sent, and they only stop or deviate based upon something that they hit, such as a container or another particle. They don't show any signs of fluid unless they're compressed.
Liquids and gases are called fluids because they can be made to flow or move. In any fluid, the molecules themselves are in constant random motion, colliding with each other and within the walls of any container.
Okay, so now I want you to say, now that you're on Google, just Google the difference between fluids and gas.
There is no difference between fluids and gas because gases are fluids. That's like me Google. What?
Okay, so if I've got water, what's the difference between water and gas?
Water is a liquid. Gas is a gas.
Is water bonded?
Yes.
Is gas bonded?
Some gases are bonded, some are not.
Is gas bonded? Yes or no?
Gases are bonded, some are not.
There's no gases that are bonded.
What do you think carbon dioxide is?
There's no gases that are bonded unless they are less
the carbon
than
not bonded to oxygen
atmos-
inside of carbon dioxide?
Okay, listen. There's no gases that are bonded unless they are placed under pressure of less than 1 atmosphere. Other than that, they are unbonded, free to go wherever they want, just like gas law dictates. And they're free to go wherever they want because there's no gravity pushing them down, holding them down. They're free to go wherever the hell they want. Right?
Gases bounce around plenty, yes, in our atmosphere under one atmosphere of pressure, which is derived from the pressure of the atmosphere.
What they don't do is dissipate into the vacuum of space, because there is no vacuum of space, because if there was, all the gas pressure that we use to breathe and all the gas pressure that's used to maintain this dynamic system would evacuate into that space.
Are you saying there's no thing as space?
It's completely absurd what you're saying.
That space exists?
He's getting
what is absurd about what I'm saying? I have proven simply everything that you've asked.
He's almost there. We're getting there. He's almost there.
But what is absurd that I am saying? Do you think that space doesn't exist?
Everything. The vacuum of space, as defined in the heliocentric model, cannot exist, because if it did exist, then the air that we breathe would evacuate into it because of the second law of thermodynamics.
No, it wouldn't. Because we have gravity acting upon the gases to hold them closer to the Earth and create an atmosphere.
Gases disperse in all directions. You've already established that.
We've given
they disperse in all directions, except so if they're dispersing in all directions,
in all directions except which one?
The gases will not disperse if a force is being acted upon them.
There's no force acting upon them. That's why gases disperse in all directions. If the force of your gravity was affecting your gases, they would only disperse down. They don't do that. They disperse in all directions.
No.
Yes. Yeah, you can say no all you like. Gases disperse in all directions.
As an atmosphere.
You've already established that earlier, mate.
Gases sort themselves.
You know, the vacuum chamber? You know the vacuum chamber where you open the little box on the inside? The gas went everywhere. It didn't just fill the bottom of the box because of your gravity.
Spurging out and screaming is not going to...
No, I'm not spurging out or screaming. You just seem to think you can talk through people.
Screaming, Matrix. You are screaming and spurging out.
You think I'm screaming and spurging out. That's
Sham, can I ask you a question? For you, gravity, it's an apple falling down. Is that correct?
No.
No.
Gravity is not going up or falling down.
No, you explained that when apple falls down, that's the gravity. I was listening.
I explained it as an object of smaller mass being pulled towards an object of greater mass.
Okay, great. If you see something falling, is that a gravity?
Yes.
Okay. Now, let's agree on that. The falling is gravity. Now, the question is, can things what is falling fall on the flat surface?
Can something fall onto a flat surface, or can something fall while being on a flat surface?
If you drop something in the air, can that fall on the flat surface?
Can it fall onto a flat surface?
Yeah.
Yes.
Can fall that on the curved surface?
Yes.
How we will distinguish if that is falling on the curved or a flat surface?
The idea of falling is relative to begin with.
Yeah, but we start with the idea. We are now agreeing. Things falling down. Okay. How we will distinguish that they falling on the flat surface or the curved surface?
I'm sorry. Could you elaborate a little bit? How do we distinguish?
Let's say that I'm on the. Let's say that I'm on the. Let's say that I'm on the building, and I take my watch and I drop my watch. Is it that watch dropping on the earth, spherical earth, curved earth, or that watch is falling on the flat surface?
I can't understand your accent. Can somebody else explain what he's trying to say?
Yeah, how about you shut up and listen and stop being a smart ass?
I'm not being a smart. I can't understand.
Yeah, you fucking well are. Everyone else can understand him except for you.
That's why I'm asking you to explain to me what he's trying to say. Instead of saying, I can't understand you, fuck you, I said, can someone else explain?
Okay, I'm saying that we agree about the falling, the things falling down, objects, what is the more dense. Now we need to realize, is that falling, that stuff can fall on the curved surface and the flat surface, and you said yes, the both. Now I want to distinguish how we will know that things fall on the flat surface and in which, and that falling, how is the example of falling on the curved surface?
I'm like dumbfounded. I don't know what he's saying. Can someone please?
Why are you invoking gravity then?
What the fuck are you talking about? Can somebody please tell
why
me
we are speaking about gravity? We want to realize that something is falling.
Vito,
okay, something is falling.
Vito,
okay, we are agreeing. We are agreeing. Something is falling. Now, is it that falling because Earth is spherical or Earth is curved or Earth is not curved? We need to realize, does that falling now influence anything about the surface of the Earth or has nothing to do with the surface of the Earth?
Sounds like complete word salad to me. Somebody please explain to me what he's trying to say.
Yeah, he's not trying to hear you.
Downward acceleration
right now. He's not trying to understand you.
No, I don't. I'm trying my very hardest. I hear that he is trying to say that something is falling, and how do we distinguish between it being curved or flat? I don't know what is falling. I don't know why. What do you mean distinguish between it being curved and flat?
Let's take your apple example, okay?
Okay.
The apple falling on the ground. Is it ground curved or flat?
The ground?
Yeah.
The ground being curved or flat is a very complicated question. From our perspective, relatively...
It's not a complicated question because the earth is in a question. That means the sphere is in the question. You want to prove some kind of force? Why? Why you want to prove some kind of force? What is the end of the conclusion? When you prove that force, what then?
Well, after I prove that gravity exists, then we know that gravity exists.
That means if gravity exists, the surface is curved. Is that correct?
Can you stop interrupting me, sir? I haven't finished explaining a single point yet. The reason to proving that gravity exists is simply to demonstrate that gravity exists. It is a fact of life. It is not something with a motive.
Gravity is things going down. Whoop de fucking do. We all see it every day. What's the causational mechanism?
Gravity is not things going down. Down is
what is the causational mechanism of your gravity?
Gravity is caused when one object moves is not caused. Gravity is demonstrated when an object of smaller mass goes to a larger one. The cause of gravity is the
awesome
mass.
So you're talking Newtonian physics. That's great. That was superseded about 110, 111 years ago, somewhere by Einsteinian. That's awesome, mate. Nice of you to keep up with the times. Yeah,
could you explain this to me?
You want me to draw it with fucking crayons?
Gravity. That was the
Einsteinian gravity, the bending of space-time.
Yes, I don't think I'm going to
superseded. Superseded. Don't you understand? You don't know what that word means? Superseded.
Yeah, no. The bending of space-time is
superseded Newtonian gravity.
Why
you do know that.
Occurs. Gravity occurs because of bends in the space-time continuum. You can demonstrate this by putting a large marble onto a piece of fabric that's stretched out, and then putting a smaller marble on that fabric and giving it a small...
And what do they all do?
You can watch it orbit.
They all crash into a heap in the middle. That's great. That's an awesome collection.
You want to know why it crashes into a heap in the middle? Is because it's being acted upon.
You do realise, listen, kids, slow down. You do realise that your so-called gravities, both of them, are just a mathematical construct to try to describe something? That's it.
No.
Science today does not know what the causational mechanism of things going down.
Let me answer it. You do realize that you're just kind of monologuing right now.
Yeah. So are you. You do know that science today does not know. Okay, shut the fuck up.
These questions or
I'm going to help you. This is how we're going to do this. You can shut up for 5 seconds, and I'm going to get it out. Science today does not know what the causational mechanism of shit going down is. Whether you like it or not, you can talk fast, you can try to explain things around it, but that's it. That's fact. Don't like it? Neither do I. Hey, that's a problem we've all got to learn to love.
Oh, are you done now? Oh, no, I was, you asked me a question, right? Before you started monologuing? Right, Matrix?
No.
No, he did. He asked, what's the causational model for gravity?
Does gravity curve the water?
Not the causational model, causational mechanism. Any fuckwit can supply a model.
The mechanism? What?
Yeah, I'm glad you were listening.
The causational mechanism for gravity in order for you to believe that it's real.
Does gravity curve the water?
Gravity curve water?
Yeah.
Yes.
Can you show that?
Hold on, guys. If you're going to be a speaker in this conversation, stay on point. Don't divert to another topic, please. I'm saying that to Sasha specifically. The gentlemen are having a conversation about something specific. We're not talking. We can talk about the other topic later. Stay on point, gentlemen. Go ahead, Matrix.
Yeah, no, the curvature of space-time is caused by mass and energy. Like I said, it's mass. Mass. It's a very simple explanation. Mass curves space-time, and that is why gravity.
Scientifically define mass for us.
Mass?
Yeah, mass. You seem to use it so often. Scientifically define it for us.
Mass is defined as like an object's either weight or its size.
That's its colloquial definition. Scientifically, what's mass?
It's the amount of matter in an object. It's matter. Mass is matter. It is a measurement for matter.
Can you cite this source for us? That'd be awesome.
That's the source for what mass is?
Your definition.
That mass is...
Scientific definition of mass. Yeah, that'd be great.
As a measure of matter? Yeah. Here.
Scientifically. This would be good.
Here you go. There you go.
Wikipedia, good boy. Oh dear. Hey, AJ, you gonna be awake for a bit longer?
Yeah, I do.
Would you like to have a chat with our little friend?
I can if you like.
Oh, cool. Because I'm sort of just about to head off. Jono was talking to him, but yeah.
Okay, well,
He's a
no, why?
staunch space believer.
What was the point of this?
Obviously, you didn't read what followed your post. Anyways, thanks, AJ. Cheers, man.
No, mass is an intrinsic body, a property of a body, right? So if I have like an apple, the mass of that apple would be the matter contained with it. It is a measurement of that matter.
He was asked to scientifically define mass. AJ, I don't know if you heard that bit or not.
When it's
Yeah, that's where I came in, but have a look at 22 minutes past the hour. Studies have shown that the amount of substance is often incorrectly identified with mass from the Royal Society of Chemistry, and nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count the number of atoms, or by any other counting method try to evaluate the amount of matter, that number would not equal mass.
Yeah, no, it's not an exact measurement.
So it's not the amount of matter, yeah?
No, it's not the number of particles, it is the amount of matter.
This is the second citation at 23 minutes past the hour. Nature does not offer us any concept of the amount of matter. So I'm sorry that you're incorrect.
Nature doesn't offer us any inclination as to the amount of matter in something?
Correct, according to Chemistry World, and that would be Taylor Edwin, Wheeler John, and that's Space-Time Physics from page 248 in 1992. At the end of the day, what Matrix was saying was correct, yeah, and you can look that up for yourself.
Oh, I'm reading it right now.
The causal mechanism for gravity is still debated today, yeah? It's not something that's settled. It's not something that can be scientifically tested and verified as per the scientific method.
Yeah, no, this is about the amount of matter. Moles is a measure of the amount of particles.
Are you looking at the citation I just dropped for you at 23 minutes past the hour?
Yes. That number would not equal mass. Isn't counting individual particles. It's in reference to the mole.
Nature does not offer any concept to the amount of matter. History has struck down every proposal to define such a term.
Yeah, the amount of matter. Yeah, I never said the amount of matter.
Which is what you were just stating, yeah? The amount of matter in something?
The amount, as in, listen, it is a measure of matter. It is a measure.
No,
that is what
it's not a measure of matter. How are you measuring matter? How did you measure matter?
Through things like weight.
Weight does not measure matter.
So if okay, cool. So is there more or less matter in a 200 or 300 pound person?
Again, we're not talking about a 200 or 300 pound person. We're talking about gravity. And you stated that it is the amount.
No, this is a
matter.
simple question.
Now,
I've
my
answered every
citation
simple
has
question you've given me, right? So you answered mine.
Does not answer any of the concept.
Well, not that you've given me, that everyone else has given me, right? No, this is just being polite. If I have a 250 and a 300 pound person, right? Which one has more matter in them?
It has to not equal weight. How many times is he going to have to say it?
They're not equal weight. Yeah. So there's a 250 and a 300 pound person.
No, matter does not equal weight.
Mass does not equal weight?
How do you know the amount of matter?
How much mass is in something?
How do you know the amount of matter when nature does not offer us any concept to the amount of matter?
What do you mean nature doesn't offer us any concept to the amount of matter? This in the side chat is about the amount.
Please.
Mole is a measure of amount, right? So a mole is 6.02 times 10 to the 23rd particles. Right? You understand this, right? It is an amount.
We're just going to ignore what's been placed in the chat after your citation from Wikipedia on mass being the being the amount of matter.
Talking through him.
So you're going to ignore what you stated, that mass is the amount of matter. When nature doesn't offer any concept as the amount of matter.
I never said the word amount.
So what did you say, please?
Mass is a measure of matter.
A measure of matter.
Scientifically, what's mass?
It's the amount of matter in an object. It's matter. Mass is matter. It is a measurement for matter.
Studies have shown that the amount of substance is often incorrectly identified with mass from the Royal Society of Chemistry, and nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term, even if we could count the number of atoms, or by any other counting method try to evaluate the amount of matter, that number would not equal mass.
Yeah, no, it's not an exact measurement.
So it's not the amount of matter, yeah?
No, it's not the number of particles, it is the amount of matter.
Did you just read the second citation at 23 minutes past the hour? Nature does not offer us any concept of the amount of matter. So
I'm sorry.
I'm sorry that you're incorrect.
Nature doesn't offer us any inclination as to the amount of matter in something?
Correct, according to Chemistry World. And that would be Taylor Edwin, Wheeler John, and that's Space-Time Physics from page 248 in 1992. At the end of the day, what Matrix was saying was correct, yeah, and you can look that up for yourself.
Oh, I'm reading it
The
right now.
causal mechanism for gravity is still debated today, yeah? It's not something that's settled. It's not something that can be scientifically tested and verified as per the scientific method.
Yeah, no, this is about the amount of matter. Moles is a measure of the amount of particles.
Are you looking at the citation I just dropped for you at 23 minutes past the
Yes,
hour?
yes, yes, yes. That number would not equal mass. Isn't counting the individual particles.
Correct.
This is in reference to the mole.
Nature does not offer any concept to the amount of matter. History has struck down every proposal to define such a term.
Yeah, the amount of matter. Yeah. I never said the
Correct,
amount of matter.
which is what you were just stating, yeah? The amount of
listen.
matter in
The
something.
amount as in listen, it is a measure of matter. It is a measure. That is
No,
what
it's not a measure of matter. How are you measuring matter? How did you measure matter?
through things like weight.
Weight does not measure matter.
So if okay, cool. So is there more or less matter in a 200 or 300 pound person?
Again, we're not talking about a 200 or 300 pound person. We're talking about gravity. And you stated that it is the amount.
No, this is a
matter.
simple question.
Now,
I've
my
answered every
citation
simple
has
question that you've
stated
given me, right? So you
that
answer
nature does
mine.
not offer any of the
Well,
concept
not
of the
that you've
amount
given me, that everyone
of
else is giving me,
matter.
right? No, this is just being polite. If I have a 250 and a 300 pound person, right? Which one has more matter in them?
Mass does not equal weight. How many times is he going to have to say it?
They're not equal weight. Yeah. So there's a 250 and a 300 pound person.
No,
Who has more matter
matter
in them?
does not equal weight.
Mass does not
Again,
equal weight.
how do you know the amount of
how much
matter?
mass is in something?
How do you know the amount of matter when nature does not offer us any concept to the amount of matter?
What do you mean nature doesn't offer us any concept to the amount of matter? This in the second. This in the side chat. It is about the amount.
Please,
A mole,
have a read
mole
in the
is a
side chat.
measure of amount, right? So a mole is 6.02 times 10 to the 23rd particles, right? You understand this, right? It is an
So
amount.
we're just going to ignore what's been placed in the chat after your citation
I'm
from
reading from the
Wikipedia
chat.
on mass being the
What you've
mass
written.
being the amount of
I'm
matter.
walking through him.
So you're going to ignore what you stated that mass is the amount of matter.
I
When
never said
nature
mass is the
doesn't
amount of
offer
matter.
any
I
concept
never
as
used
the
the word
amount of
amount.
matter.
I never said the word amount.
So what did you say, please?
Mass is a measure of matter.
A measure of matter.
Yes.
So that would be the amount of matter?
No.
So how are you measuring matter?
Through things like weight. That's how you measure. That's how you measure mass. Mass is typically measured in things like kilograms.
So a measure of matter attracts a measure of matter.
No. Two measurements don't attract each other.
That was your gravity, mass attracting mass. That's your mass attracting mass.
Well, gravity is not mass attracting mass because gravity has no matter.
A mass colloquially.
Has no mass, sorry.
A mass colloquially
Gravity
could
itself-
also mean a large object, right?
Gravity itself has
That's
no
correct.
mass.
A mass is two definitions. It could also be a large object. Is this correct or incorrect?
It's also a large gathering of people at church.
Yes. Yeah, no, and the way
There's
I was
three.
using it when I was defining gravity to you was saying an object, a mass.
So, again, what is mass?
he said scientifically what is mass. If you want me to define what mass is,
and then
to you,
you said
which
that mass
definition
was
do you
the
want?
amount of matter.
No,
Are
not
you
an
going
amount
to
of
renege
matter.
on
That
that
is
now?
not what mass
We have to
is.
go back into the recordings and listen to it again.
Yes.
At the end of the day, the statement that Matrix made was correct, and it's something that you can look at for yourself, yeah? At
This
the
is
end
the
of the
science
day,
map that I am describing to you.
they do not have any evidence for the causation of gravity. It's something that's still discussed and debated today. It's not settled, and it's not science, as it cannot be tested via the scientific method.
Okay. I want you to understand first this piece of evidence that is presented in the side chat, right, AJ? Nature does not offer us any concept as the amount of matter.
All right, so it's either, I'm going to give the distinction to the gentleman. So it's either the amount of something or the weight of something. You're going to have to pick one of those. Which one do you think it is?
No, that's a false dichotomy.
How much something, yeah, relax it. Is it how much something, like if you're talking about an apple, how much something is within that apple? Like how matter would be the constituent parts that make the apple up, as in the amount of something? Or is it how much the apple weighs? You're going to have to make a distinction which one that is you're talking about.
Amount is something that is measurable in something like a mole. But weight is relative. The weight of something changes depending on where you are, depending on how much the force of gravity is acting upon
or
it.
is it the amount of stuff? Is it the amount of stuff that the apple has, or is it the weight of the apple?
The mass of an object?
Matter is not weight, my friend.
Matter is not weight. Yes, I agree. Weight is a way to measure the amount of matter in something.
Go ahead, AJ.
It is a way to measure the effect of matter on. It's a way to measure the effect of gravity on matter. So if something weighs 150 pounds, it means that the Earth is pulling in 150 pounds of force with that thing. That is the weight that is acting upon it. So if you go to Mars, right? Mars has a way weaker gravitational force. So that thing would weigh less. The scale would read a lower number.
Hang on a minute. Stop. Aren't you supposed to be using your weight/mass to prove gravity? And now you're just reaffirming that?
No.
Hang on a second. Prior, he was saying that matter was the.
I'm explaining
the
how
amount
weight is relative.
Of matter, and now he's changed it to weight. Yeah,
in fact,
when matter itself isn't weight.
Why does the same amount of matter, right, weigh a different weight on the Earth and on the Moon?
Matter's not weight.
You've done this to confirm it.
Scientists have. Several scientists have.
Cool story, bro.
You said matter's not weight. Weight is a unit of measurement, my friend.
Yes, weight is a unit of measurement.
We get measured traction, Timmy.
Yes, it is a relative unit of measurement.
It's a unit of measurement.
And it's relative.
As long as you say the word relative,
weight is one of the only units of measurement that is completely relative. An inch is an inch no matter where you are in the universe. But a pound is not a pound no matter where you are.
Is it the amount of something or is it the weight of something? That's what you haven't defined yet.
It is neither of those.
So matter is
so then what is
weight?
it?
It's neither the weight nor the amount. Matter is the thing that is causing the weight. But not, that is one of the two components causing the weight. Matter is an mass is an intrinsic property of matter.
And what is matter? Please, the scientific definition.
A solid, liquid, or gas, or plasma, or antimatter.
Can you please cite that for me? The definition of matter. So we're back to where Matrix left off, yeah? We've gotten nowhere.
Matter refers to anything that has mass and takes up space.
So, weight.
No. Weight does not take up space, and weight is not mass. Weight is a measure of matter. It is a way for us to measure it. It's a relative way for things to measure it. You keep on telling me to define and source things like all the fucking time. When is this gonna prove to me that pictures of the Earth from outer space are fucking fake?
Well, first of all, yeah,
space is fucking fake.
Yeah, you're
what
very
part of that don't you comprehend? Sorry,
hold on, guys. Yeah, you're confused as to what you're confused as to what matter and mass are. You don't know how they're defined, so you're all over the place. So you're a hot mess. So you can't define what they are. So you don't know what they are, and you're misappropriating.
I can't hear you over your vacuum.
At the end of the day,
You can't hear him if you're talking while he's talking either.
No, I can't. But you can't hear me either. Nobody knows what the fuck he said because there's a vacuum.
Sorry about that. Go ahead, AJ.
Can you please turn on noise suppression while you're talking? Because when you're in between you talking, I can't hear the background noise. But as soon as you start talking, it is
cry harder, please.
From AV, whenever he starts talking, it's nearly impossible for me to tell what he says.
It's okay. I can hear AV. I can hear him quite clearly when he speaks.
Could you relay what he's saying to me? Because it was like ear piercing.
Sometimes he can't understand people, and sometimes when he can't define words, he obfuscates. Yeah.
You cut out a lot when you were saying that. Could you repeat it? Could you repeat that? You cut out a lot when you were saying it.
Yeah, he's not talking anymore. Let's move on.
No, you, I meant.
Yeah, he's not talking anymore. Let's move on.
No, whoever is saying he is not talking anymore, I'm talking to you. You cut out a lot when you were saying what you initially said.
Yeah, that's what I was saying. Let's move on. Let's stop whining and move on.
Okay, so how do you prove that
the amount of matter
is a mole?
Does not equal mass.
That is a mole. A mole is the measure of an amount of matter.
The amount of matter does not equal mass.
No. An amount is a measure, is like a counting measure. So if I have 5 apples, right, the amount would be 5. So if I had 6.02 to the times 10 to the 23rd particles, that amount would be 1 mole. And a particle is matter because it has a mass and it takes up space. It has a mass and a volume, so it is matter.
So mass is weight then?
No.
Why does it seem every time you say that word, it gets changed from one thing to another depending on your context?
Weight is a relative measure of mass.
Relative to what?
Gravity.
But you're using mass to define gravity. Mass attracting mass.
Yes.
So you're what?
Not necessarily. Yeah, mass attracting mass. That is gravity. A larger mass pulling a smaller mass into it. That is gravity.
But we've already established that was superseded 111 years ago, thereabouts.
No, it wasn't superseded. That didn't suddenly change the definition of gravity.
It was superseded.
Why gravity happens.
Stop talking. You're making noise unnecessarily. It was superseded.
Superseded? Define superseded.
Taken over.
How is enforcing the other definition taking it over?
It's not enforcing the other definition.
Yes, Einstein's definition enforced the Newtonian definition of gravity.
No, it didn't actually. They're actually completely in opposition.
How are they in opposition?
All right, give me a second. I'll drop some stuff for you.
No, I want you to define it in your own words.
Yeah, I will. I'm going to cite it for you.
Okay.
Okay, so give me 2 seconds. I'm going to start with sorry, I'm just doing a search. So from University Today, we have In general relativity, gravity is not a force.
It's not just a force. The word just is in parentheses.
You can shut up and let him finish.
What? Why would I? I'm correcting him because he
In
misread the
general
title.
relativity, gravity is not a force between masses. Again, from physics.org. According to this general relativity, gravity is not a force. All right, so we've got two separate things that are not complementing each other, yeah? Because in Newtonian mechanics, gravity is a force that acts at a distance, which states that every mass attracts every other mass with a force that's proportional to the product of the mass. In Einstein's theory of general relativity, gravity is not a force, but a manifestation of the curvature of space-time caused by the presence of mass and energy. There's a massive difference there, yeah?
I call into question the validity of this .com source because in the following sentence they say
Yeah, no
without a
worries.
force.
Well, I can drop you another
Could I
100
please
if you
finish
like.
what I was saying? Could you shut the fuck up and let me finish? So it
No,
says in
I
the
won't
following
shut the
sentence.
fuck
It says
up
in the
because you're
following sentence. It says
spiraling, my friend. Physics Libretext. Newton's two crowning achievements, the laws of motion and the laws of gravitation that had reigned supreme since published in the Principia in 1687, were toppled from the throne by Einstein. Now, if you would like me to continue giving you a comparison between Newtonian mechanics and general relativity, we can.
Oh, I'm unmuted now. Okay, as I was saying before you rudely interrupted me, without a force...
No, I didn't rudely interrupt you. You rudely interrupted me with a little spiral stating that what I've posted here is incorrect. So again, at 41 minutes past the hour, Newton's two crowning achievements, the laws of motion and the laws of gravitation that had reigned supreme since published in the Principia in 1687, were toppled from the throne by Einstein. Physics Libretexts.
Okay, I can talk now, correct?
No, keep
Are
him
you
muted
going to
unless he can
address
cite a
what I
different
just put
source.
in the chat, or are you going to keep whinging
This source is
without
incorrect.
moderation?
This source is
He's
completely
going to keep
moot.
whinging.
This source is invalid. It's a...
Oh, it's
In the
not a valid
following
source.
sentence... In
So
the
Physics
following sentence...
Libretext is not a valid source of
I'm saying that
information.
the Universe Today source is completely incorrect.
Okay, so we can ignore that one because I've dropped another 2 or 3 there, yeah, but they're all in agreement with each
Ass
other,
clown.
whether you like the source or
Quantity
not.
over quality? Is that what we're going for?
So did
now?
I. So
I'm
did I,
taking these one
AJ.
at a time. Okay,
Wait. I need you to define in a critique how it's incorrect because it comes from a source, the citation that AJ just
yes.
gave you. You're going to have to define the critique as to how it's incorrect. Go ahead.
In the following sentence, right after the sentence in which he quoted, it says, without a force acting upon it, an object will move in a straight line. That's impossible.
Well, that's Newton.
If an object has no force ever acting upon it, it will move in a straight line. If an object never has force acting upon it, it will stay at
In this
rest.
example, your critique, but basically, what AJ was demonstrated to you, how Newton was superseded by Einstein's bending and warping of space-time. So what is your critique on how that's incorrect, that it was toppled from the throne? This is what we're demonstrating to you, which you're saying that it's not, it was just building upon, and it's not building upon, it's actually removed completely, and it does not work. And so Einstein's general relativity theory was what superseded the Newtonian idea of gravitation. So you don't know how that is, and AJ is pointing out where that was actually toppled from the throne 100 years ago. So you keep thinking it's relative.
In the source where this is talking about, where this is talked about.
He just demonstrated to you. AJ's going to post it again. I mean, it's in the text.
Well, at 43 minutes past the hour, I'll go with one of your own sources, Wikipedia. Newton's classical mechanics was superseded in the early 20th century when Albert Einstein developed the special and general theory of relativity.
The theory of relativity, yes.
Yeah, so toppled.
The point keeps going right over his head.
From the throne, yeah?
So does this mean that Newton's laws are completely
that
correct?
his two crowning achievements, motion and gravitation, were also toppled from the throne.
So then why do they teach
Now,
Newton's law?
would you like?
Why do they teach
would
Newton's
you
law
then-
if they were supposedly toppled?
Would you like me to continue with the comparison that you asked for that you rudely interrupted?
Go ahead. Go ahead. Go ahead.
Yeah, no worries. So again, in Newtonian mechanics, gravity is a force that acts at a distance, which states every mass tracks another mass. Einstein's theory of general relativity, gravity is not a force, but the manifestation of the curvature of space-time. So, completely different. Space and time, Newtonian mechanics, space and time are independent and absolute entities that provide a fixed stage for physical events. However, in general relativity, space and time are interconnected, they're dynamic, space-time, and influenced by the distribution of mass and energy, which leads to the concept of space-time, where distances and durations are not fixed, but relative to the observer. So we've got fixed or not fixed. Space is not expanding in Newtonian mechanics. In general relativity, space is expanding.
Okay, yes, and I can see. Relativity is much more accurate than Newtonian physics. Yes, I can see.
You've also got
Newtonian mechanics. Cool. Time is absolute and unaffected by gravity. In general relativity, time is relative and runs slower in the stronger gravitational field. Newtonian mechanics, gravity affects objects with mass. Light having no mass should not be influenced by gravity.
Yes,
Einstein,
I agree with
light follows the curvature of space-time. So far, can you please explain to me how these two somehow go hand in hand, and that Einstein just further explained
that light is affected because light is both a particle and a wave. It has mass. Photons have mass.
No, you conceded. You conceded. They're two different things, and they conflict. They contradict you to one another. You conceded.
No, I conceded that Newtonian what is it? The theory of relativity supersedes Newtonian physics.
Okay.
Not that these are contradictory.
Oh, it's not a mass attracting mass then.
Yes,
no, it's not mass attracting mass. I explained that in very simple terms. If you want me, I am not educated in the theory of relativity.
Now we're going to talk about the theory of relativity that's not a scientific theory, yeah? Because there is no established cause and effect relationship here.
Does there need to be a cause and effect relationship? This is an observation.
OMG, what is science?
Okay, so your observation, right, is the effect that things fall down. So how did you come to the causation of bendy-warpy space-time? Like you said, it's an observation, things falling down.
Yes.
Okay, so now how do we go from the observation of things falling down to causation, bendy-warpy space-time?
Because the gravity, it is being pulled from the apple is being pulled from its current position towards the Earth, which is relatively down to us because of the Earth.
There you go with
it's not being pulled down because it's not a force.
Not a force.
No,
there you go again, reverting back to Newtonian again.
It's not being pulled down. It is moving downwards.
Correct. Okay, so now we witness the effect. The effect is not the cause, which is the way that you're stating it here. You're somehow making the effect cause. The effect itself is what you witnessed. Now we need to discuss the causation of that effect. What made this thing go down?
Why are we playing the semantics? What does that have to do with my original question?
Well, we're not playing semantics. We're establishing the causation for gravity that you have claimed. We're going to see if that is in fact correct.
How do you explain the fucking pictures of Earth from space? Do you believe in Newton in the theory of relativity?
Well, the thing is that we can throw out anything that's a violation of natural laws, and your pictures from space are a violation of natural laws.
How are they a violation of natural laws? How are pictures from space a violation of natural laws?
They are a violation of both gas laws and thermodynamics laws, in particular, entropy of gases.
Why?
Why?
Gas expands in all directions to fill available volume. That's one of the most cited instances of entropy taking place. Is the free expansion of gas into a vacuum.
Why are you using something as a counter argument that you don't believe in the
They claim
first
that
place?
Earth has a fixed volume of gases surrounding it, which is not expanding into an available volume of a vacuum of 10 to the negative 17 torr, and of astronomical proportions.
Why are you using something as an argument that you don't believe in the first place?
What are you talking about?
We do believe in natural laws.
This
We
guy's an
believe in
idiot.
gas
You believe in natural
pressure and
laws?
entropy.
Oh, no, wait. So you believe in every natural law except for gravity?
You don't need to believe in natural laws. You don't.
Gravity's not a natural law, ass clown.
One sec. You don't need to believe. Belief is not required with natural law. It's observable and demonstrable. It's knowledge.
Correct, T-Dub. Thank you. And
gravity's not a natural law.
Is space real?
As it's described to us, no. And you don't have the ability, and
how is
neither
it
do they,
described
to
to
go
us?
there.
And how is it described to us?
I'd like you to show me that it is. But you can't.
I can show you people who have proven
Well,
space
again,
is real.
it's
I can show you
described.
people who have been to space.
Space is described as a vacuum, a near perfect vacuum, 10 to the negative 17 torr vacuum, next to a pressurized system without containment.
Oh, yeah, no, I'm reading the same exact Wikipedia page you quoted, by the way, as we were talking, and it says the attractive force of gravity arises due to an exchange of virtual gravitons in the same way the electromagnetic force.
OMG.
This is
He's
quantum
retarded.
gravity.
We're going to go backwards, are we? We're talking about gas pressure,
because I just found a piece
and
of
we're
evidence.
talking about
I was
gas
stumped on
pressure
an
and
answer.
entropy.
No, you said that gravity isn't the force, but it is.
No,
Gravity
it's
is a
not. We've
force
already
according to quantum
established that
mechanics.
it's not a force.
Yes, it
He's
is.
retarded.
No, look, it says right here it was superseded again by quantum mechanics.
So, as per my original statement, it is still not settled, yeah? It is not something that they can
Science
test.
is not something that becomes settled. Science is ever-changing and flowing.
So you're saying that the scientific method cannot establish a cause and effect relationship?
It is a reasonable pathway to truth. It establishes a cause and effect relationship based on things that we can observe.
Yes. Why are you arguing vehemently for something that is not settled? What is that all about?
Because there's evidence for that thing.
No, it's not. If it's not settled, there's no evidence of it. It's not settled.
No, it is not settled because new evidence is brought to light. That is when it becomes not settled anymore.
So something's settled until it's not settled? That's ridiculous.
Yes, and it's the same way that something can become more and more and more and more
He identified the problem for himself. He said science doesn't prove
If I
things
say
and it's
somebody
ever
is,
changing. He
if I
said
say
science is
somebody is
ever
about 6
changing
feet
and it
tall,
doesn't prove things. How so?
if I say someone's about 6 feet tall, and then I later measure him with a more accurate thing, and I say he is 6'3", and then I measure him even more accurately and say he's 6'3¼ right? Should I
Well, he
listen
was
to
never
somebody who
6
says
foot or
that he?
6'3", was he? He was always 6'3¼ and you made assumptions like you're making about your gravity.
No, I made the most reasonable.
Your assumptions are not science.
Can you please let me finish? I've been interrupted basically every time I try to talk. And you have the most specific measure that you could possibly get when you are measuring him at 6'3". And then as the measures become more accurate, we gain new information and we become more specific. That is what happens with science.
That does not negate the already established facts. It does not invalidate already well-established scientific fact. For instance, do you think that maybe sometime in the future, type 2 diabetes will not be a result of a lack of insulin?
No, I don't believe that that's going to reasonably change.
Right. Okay, then.
I have no way of knowing if it's going to reasonably change, but I don't personally believe it will.
And we're discussing natural laws at the moment, yeah?
Yeah, what does
Not
that have to do with your diabetes?
Well, you've taken it back to science, but I'm stating that we're talking about natural laws. We were talking about gas pressure and entropy of gases. You asked what the claim of state
it's
is,
held down
and
onto Earth because of
I
gravity.
clarified that for you, being a near perfect vacuum next to a pressurized system. That is a violation of natural laws, like I stated.
Could you repeat that?
I said, you took us to space. You asked me the question about space, and I said, no, I don't believe space to be what it is claimed or taught to be today. And you asked me, what is that? I clarified that for you and said that it's claimed to be a near perfect vacuum, 10 to the 17 negative torr, next to a pressurized system. This is a violation of natural laws that is not possible.
Why? Why is it a violation?
So that is why I don't believe what they tell me about space. Why? Because the antecedent requirement to gas pressure is a volume to fill. That volume requires containment, right?
Yes,
so that's
it is
the
contained
first.
by gravity.
That's the first, yeah? Secondly, we've got entropy of gases, which is one of the most widely cited forms of entropy, right? So gas expands to fill the void. Space, the void, would be filled by the gas on the Earth. We would no longer have gas pressure.
Yeah, there is no stopping the expansion of
the gas into it.
There's no stopping the expansion of gas without physical containment.
Yes, the force of gravity stops the expansion of gas.
Okay, go ahead and demonstrate
Gravity's
that.
not a force. We've already.
How is a force again?
Gravity
Oh
is
my
a
God!
force. Could I have a
Can you
image?
please demonstrate for me gravity affecting gases?
I can demonstrate to you gravity affecting gases. Yes. Do you have a telescope?
You have to reproduce it. Like
do you have a telescope?
Why do I need a telescope?
No, bro. No. No, you're not looking into the sky and begging the question and saying, look at that. That's a gas ball. It's surrounded by a vacuum and the gas isn't expanding into it. No, that's the thing in contention. You have to demonstrate it, as in replicate it, as in produce gas pressure using gravity.
That's impossible. It would require a massive.
Okay, there you go. Thank you. Concession made.
I could not.
Impossible. It's impossible.
No, it is
exactly.
not
That's what we're telling you. It's impossible. We're agreeing. You agree with us.
Can I finish
that's
saying
the
what I was
end
saying?
of the argument, bro. That's the end of your argument.
T-Dub.
Yeah, he lost at T-Dub. Yeah,
that's the end of your claim.
My sentence.
There is no finishing it. You just agreed. You agreed with us. It's impossible. We agree. That is impossible.
It's impossible for me personally to reproduce it. That doesn't mean it's impossible.
Yes, it does.
I can't go out into space and create a fucking planet.
There is no space. Planets aren't what you think they
circular.
are.
That's circular. You're trying to.
Nobody can create a fucking planet. It requires an incredibly large mass to demonstrate this.
It's
a mass that I can't procure.
You're trying to go out there and prove something that you can't do down here.
You can't do it down here because of the gravity of the fucking Earth.
Again,
well, you get
what you're doing.
You can't prove it down here, so how can you make somebody believe that it's true?
Because space is a vacuum.
How do you know that it's circular? Are you going to point to a gas ball that you can't prove because you can't make a planet?
Yes, you can't prove that the gas ball is real because you can see it with your own fucking eyes.
How do you know it's a gas ball? Tell everybody here how you know it's a gas ball.
How do I know the fucking?
Somebody else said so, dude.
How do you know Jupiter's a gas ball?
You can see the swirling masses of gas. You can see the eye of the storm that is constantly on its surface.
How do you know it's gas?
I don't think this guy owns a telescope, AV. I don't think he owns a telescope at all.
If you had a powerful enough telescope, right?
No, dude, don't worry about it.
If you had a powerful enough telescope that could see
don't worry about it. Don't worry about it. Don't worry about it. Don't worry about it. How do you know the constituent parts of what you're looking at? I want you to define how the material that you're looking at is what it is. How do you know that?
We can do this, right? Science has done this by looking at their electromagnetic spectrum.
Sham, what you've done is you've given the example that you've given earlier. You said that, you know, we look at this guy and we look at him across the pathway or the road or wherever we see him, and he appears to be 6 foot, so we think he's 6 foot. But when we actually go and measure him directly, we find out that our assumption was just an assumption. It was incorrect. He was actually 6'3 1/4". So you may want to look up at these planets.
And when we send probes
and
to
just
Jupiter,
make
we can find what
assumptions about what you believe it may be, but there's no way that you can verify it.
Yes, and we have sent probes to Jupiter to verify this.
We've sent people into the violation of natural law.
Probes, not people, probes.
Yeah, so you've sent probes into the violation of natural laws. You've gone
It is
through
not a violation of natural laws because it is a real thing. Human beings have sent probes to Jupiter.
He's spiraling and he isn't listening at all.
Yeah, you just got validation. That's not
Echo
validation
chamber.
of the
You're
thing
all
being what you
retarded
say it
as
is.
fuck. Kill yourself.
No, okay, he spiraled all the way out. Yeah, he needs to be banned now. Later, dude. He just violated TOS, so somebody get rid of him.
I think he's gone already. I think he said that and then just ran instantly.
Yeah. Because don't take my outer space, damn it.
Yeah, exactly.
I got to do a little bit more research on this mass thing. I got to get a bit more. I got to do a bit more research on this mass thing. Yeah, I've got to get a little bit better on that.
At first, when I tuned in, I thought y'all talking to AI.
No, my machines are loud as fuck, so it was hard for me to get in there. Good to see you guys here, lively in the chat. (24/7), always keeping it on point.
Yeah, I was going to throw in real quick, Mig and everybody. I listened to that guy for the last hour, and basically y'all reduced him to, I could prove my fantasy story if I just had access to my fantasy story. And that's what most of them are reduced to. They think they can prove something out of the sky.
That's a good way of putting it, Dave.
What was funny is that he was saying that he can point to Jupiter and see swirling ball of gas. And it's like, dude, how did you define that was gas? Like, how do you know it is? Oh, we sent probes up there. Really? We? Yeah, basically another assumption, right?
Sounds like he's just emotionally attached to the narrative.
People have been wording things really well lately. Like New Perspective, they said yesterday or the day before, he's talking to a fellow and he goes, would it really surprise you that much that reality turns out to be exactly what you observe and experience it to be? I like the way he said that. That was like, because what does someone say to that?
Yes, so did he give you a new perspective, Cheeto?
yeah, you could say that. Yeah. Like, what is the answer to that? Yes, that would surprise me, right? Like, that's stupid. Would it surprise you that blue is actually blue, right? You know, like, or a dog is a dog. Like, that's the same sort of fucking thing.
Usually ask people if they're new is, would you want to know, right? And most people will say, yeah, like, of course, we all want to think we're open-minded, but would you really want to know? Like, if we could tell you exactly why, and then you could go look into it and find out that we're right, would you want to know? And then there's a caveat to it as well. What if most people still won't want to know, and you're going to have to live the rest of your life knowing it's not a ball, but most people are still going to believe it is? It's kind of like taking a permanent hit of acid, I say, in a way. Because it's like you're tripping because you stop tripping and everybody else is still tripping thinking they're spinning on a ball when there's no evidence for that whatsoever.
No curvature. Where's the curvature? Where?
No motion. It's just like it seems. Would you be really that surprised to find out that reality is like it seems instead of the opposite? Hey, Israel, have you ever heard of a term called base axioms? You ever heard of anything like that? Base
I
axioms.
haven't. No.
Okay, so your base axioms are like what you personally experience, you yourself. Like if you're sitting in a chair, you're just sitting in a chair. You don't have to believe you're sitting in a
Right.
chair because you know you're sitting in a chair, right? It's like the direct experience of sitting in a chair isn't a belief. It's just that's just what it is, right?
Right. Right.
Okay, that's what we mean by base axiom. So like if you were born on this earth, let's say you were never told anything about space or the interpretation of the earth being a planet or anything like that. Sometimes we'll ask people on the ball side, but if they'll at least admit that if they were born here not knowing anything about space or the stories that they think are true, they would just assume, right? Like rightly so, that it's stationary and level, right? We would all assume that. That's why they supposedly
Right.
they thought it was stationary and flat for thousands of years, right? Before the last
Right.
200 when they supposedly discovered we're on a planet and all that, right? Or whatever timeline,
Right.
doesn't
Yeah.
matter.
You're
Thousands
right.
of years they thought it was stationary and level because that's what they directly experienced, right? They didn't have
Yep.
any
You're right.
idea that it could be a planet or any of that kind of stuff, right? So that's your
Yep.
base axioms, right? So that's where you're starting with. You start with your base axioms, and if there's reason to believe that it's not what your base axioms are telling you, if there's reason to believe it's not stationary and not leveled, just like it seems every day, 24/7 for every person ever, right? Then that becomes the belief, right? Because you're not believing it until there's good reason to think that it's something other than that, right?
Well.
So
Well.
the burden of proof
What's
is on the people that saying we're spinning and flying through space because we don't experience that at all. That's what these guys are trying to tell you.
okay? So what's telling you that the base? What did you say? The base axiom? Is that what you said?
Base
So
axioms.
what's telling you that that's anything different?
Well, it's just what you experience, right? It's what you would rightly assume
Is it?
because it's what you
Is
directly
it?
experience, like sitting in a
Does
chair.
it happen to be? Hold on. Does it happen to be like going into space and looking at shit?
What do you mean?
Could that be it?
Well, if you
You know.
directly went to space yourself, then you could call that your base axiom when you're in space looking back at the Earth. You could say, I objectively see the Earth, right? But you don't do that. You're just told that people do that.
Oh, wait. Like I don't do it. You're right. I don't do that. But
Or you believe
so
people have done that, right?
okay. So maybe I believe people have done that. But so you
We all did.
believe? What did you believe before that?
Yeah. Well, we all
Why
did.
do
We
you
all we
believe?
all thought like exactly like you do. We all thought it was real. We didn't want to think it wasn't real. People don't want to become flat earthers, bro. We're like, no, don't tell me space is fake. We all think we could debunk it, like right away. We wouldn't want you to believe us. We won't want you to leave this room saying, "Oh, you convinced me." That would be the worst thing that could
So
possibly happen
hold on.
because you're just believing
So
us
which
then.
one are you? I mean, so you believe what you were told before?
No, we
You know,
all did. I'm
before they
saying we
thought the Earth was
all
a globe.
raised believing
We
that,
all
right?
did. We all did.
We all assumed that the space stuff was real, right? We thought people went up there. Then we looked into it, and it's just not even close to real. It's like beyond fake. It's like the worst
So
magic. Like if we went to a magic show and the magician is the worst magician ever, right? Like nothing he did was
okay.
at all believable.
No.
Like he's got the rabbit. The rabbit doesn't disappear. None of it works. But then you're coming out of the
Okay.
show going, wait, that none of that was magic, and your friends are going, dude, he totally did magic. That's kind of what's going on here.
Okay.
If you look at it critically, bro, you're going to go, wait a minute, this is a really bad magic act. It's not even close to believable. If you really want to, like, look for a reason to criticize it, you're going to find that. But
Well.
that's not the reason that
Well.
people think the Earth.
Why doesn't most people? Why don't most people think that
Well, because they haven't
when they
looked
look
into
at?
it and they don't wanna. They don't wanna think it's fake. We all wanted to hold on. Dude. I was a Star
I
Trek
don't know, man.
junkie. I was a
Believe.
Stephen Hawking like nut, dude. I bought both his books. I was like highlighting every other page. I bought
Oh.
both special editions of Universe in a Nutshell and Brief History of Time. And I used to talk about how the universe is, the quadrant of the universe that's at the edge of a wormhole. and you can get to the other part of the universe faster if you go through the wormhole, and it's all enveloping in on it. And I used to think I was smart because I thought he was telling the truth, right? He was telling the truth, right? No, most people that become flat earthers are space junkies. A lot of them are interested in all the science of space that we were told,
That's
and that's
right.
why a lot of us are here for that. No, that's not. No one believes in the firmament. You can believe in a firmament if you want, but that's just like we don't. If you're talking to somebody that knows what they're talking about, that's a flat earther, that they're not trying to claim anything that they can't directly show you, right? Because that's what got us into this problem. Believing people, right? If someone said there's a firmament and you just believe them, that's just as bad as believing them what they're saying about space. No, that's not. No one believes in the firmament. You can believe in a firmament if you want, but that's just like we don't. If you're talking to somebody that knows what they're talking about, that's a flat earther, that they're not trying to claim anything that they can't directly show you, right? Because that's what got us into this problem. Believing people, but if someone said there's a firmament and you just believe them, that's just as bad as believing them what they're saying about space. If you're believing, the lie is in the middle of belief for a reason. Yeah, faith. That's the problem. See, I'm not saying faith is bad. I'm just saying that if you're talking about your whole paradigm, right, you'd want to be able to confirm what you're told to some extent. But everything's so conveniently. Oh, you can't feel the spin. You can't see the curve. Oh, it's like the bad magic act. Like, look over there, and I'm going to hide this thing behind my back, and you're not going to see it because you just can't see it. I'm too big for you to see the magic act. I'm too slow for you to see that I'm not doing it right. It's like all this like fucking gaslighting, dude. It's major gaslighting when you really go crooked. But nobody wanted to think that. We all ran away from flat Earth. We all ran away from flat Earth because we realized that the lie would be too big, almost too big for us to psychologically handle it first, right? It's too big. That's why they did it that way. They made it so the lie is so big, most people would not want to know if they're lying or not. That's the trick. That's how they did it, bro.
New perspective. You and a few other guys I've heard in here. Come on, you guys are smarter than this. I mean,
Well, you
why
would
are you
think,
even
but
in
you're
here?
still assuming, right? You heard what assuming does. It makes an ass of you and me. We all assumed that there's no way people think the Earth is flat, right? And we don't even look at it for months, years, maybe never, right? But the people that are curious enough to take a second look and look into it, like you might walk away from this conversation,
Dude, come
never look
on.
into it, right? You can go your rest of your life and never think
I don't
about it again.
need to look
But
into it.
yeah, you don't even
You
need to,
are
right? So why are
way
you here
smarter
talking
than
about it,
that,
right?
bro.
Isn't it a little bit
You are
weird that a
way
lot of
smarter.
seemingly intelligent people, right, are talking about that they do not any longer believe that people go to space, right? We intelligently came to that conclusion. Doesn't that make you suspicious that there's something going on here? Either we're lying, you're right. Either we're trying to trick you into thinking it's fake, or right, or there's something more to it. But that's for you to find out. You have the option to look into it for yourself now. I'll send you links if you like. There's
Yeah.
lots of information. Or you can just assume we're stupid, which you know isn't true already, and just go about your life. You, regardless of who they are, that you're dizzy, but you know you're not dizzy, right? And you're not going to take their advice because of that, right? What if they said, "Oh, well, you've been dizzy your whole life. You just don't realize it because you've gotten used to it."
No, I see where. But that's completely different, though.
That makes
Dude,
Well,
what?
total
it
sense.
is different, but the point is
That
that
doesn't make
if
total
you live,
sense,
here's a
dude.
better way of looking at it.
Anybody?
Like say, well, there's a better way of looking at
No.
it. If you live near the North Pole, where they say it doesn't spin at all, like at the North Pole, they say that the Earth doesn't spin. It's up because it's at 0 miles per hour. Then it tapers down to the equator, where it's supposed to be 1,000 miles an hour, right? So you would live your whole life near the North Pole, where you're not spinning hardly at all, right? And then you move to somewhere on the equator, and now all of a sudden you're spinning at 1,000 miles an hour. Do you think you'd feel it then?
I don't know, man. I've never done it. I've never moved that far away.
Well, but wouldn't that be a phenomenon you could Google and someone's had that experience? You would think that'd be common, right?
Maybe.
Yeah,
Yeah.
you'd hear about it. The people moving from where they say it spins slower to where they're saying it spins faster. It would take a lot of getting
But
used
how
to.
many people live, where it's not very fast?
There's people all over the world. They say it's 500 miles
Really?
per hour, like halfway to there, right? So a lot of us are living where it's half the speed, supposedly. Does that make sense? Does that make any sense at all? That we're all
It
spinning
makes, yeah,
at
dude.
different
I
speeds?
mean, you are making sense. I for real. But how many people like live way up, like where there's no
Regardless, it would
spin?
be even if it was rare, you would hear about it. You hear about people going from
I'm
living in
not
an area
sure,
where it
dude. I
doesn't
mean,
spin as much as the equator
it's.
does. They move there and
I
they
mean,
had this like shocking, adjustment period at the very least. But you don't hear anything about that.
Ever.
but how many people move from there to the middle of
Well,
the earth? I mean, it doesn't
but you get
happen
my
very
point,
often.
right?
It's-
You get my point. If
I do
that was
get. I do
something,
get
if
your
the Earth
point.
were spinning, you would hear
Yeah.
about something like that at least. Something there's no evidence for that whatsoever.
No curvature. Where's the curvature? Where?
No motion. It's just like it seems. Would you be really that surprised to find out that reality is like it seems instead of the opposite?
Fire's hot. Reality.
So, yeah, I mean, I appreciate that. That was a good way of looking at it, new perspective.